get, we can go back and we can redo it as much as we need to. But this is the last chapter. We are jumping from 6 over to 8 because we're not going to be able to do 7. It's just way too big, and the ideas are much tougher. So we thought we want to go to 8, much simpler, kind of finish it off. Chapter 8 has to do with roots, and I think you guys have all done radicals before, right? Radical. So that's what I mean when I say roots. So let's get to it. Slideshow from current. So chapter 8, section 1. Come on. Here's our objectives. There are 5 objectives for this section. Radical expressions and their graphs. So we're going to find the roots of numbers. And when we say roots of numbers, we're really talking about using those radical symbols. The square root, the cube root, the fourth root, the fifth root, whatever it needs to be. So we're going to be finding roots of numbers. Find principal roots. We're going to look for principal roots. We're going to graph functions defined by radical expressions. So take a look at what those graphs look like. They're actually quite simple, so don't let that intimidate you. We're going to find the nth root of nth powers. So no matter what root and what power it is, and that means you're taking the root of something that has a power inside. And you'll see what we mean when we get there. And of course, the last one, if we don't get to it, that's fine. I think you guys have done those on calculators long enough that you can find the root using a calculator, right? It's that second x squared button. Right. Well, there's another one where you can find the nth root, and it's actually a feature that's hidden inside the calculator. But I'll show you where that's at, okay? So let's get started here. So finding roots of numbers. Everything has an inverse operation in math. Whenever you do something, you have to be able to undo it, right? Opposite of multiplication is division. Opposite of addition is subtraction, so forth, so forth. The opposite of the distributive property, which we used before last week, was to factor. Okay, so those things undo each other. Okay, so the opposite of taking some number to a power, Alberto, would be to take the root of that. How are you? I've missed you so much.
You're beautiful.
I can't even tell you how much I've missed you.
You should have FaceTime more.
I don't have your number.
Yeah, let's keep it that way.
You have to give me those digits. But how about I hear that one? Give me those digits, bro. So anyways, so when we're talking about the square root of 36, we're saying we already did some operation to this number. And in this case, of course, you guys know there's a 2 up here, right? Inside above, and you really can't see it that well, but it's right there. There's a 2 there. You see it? Okay. So we're saying that we took some number and we squared it. And all this is asking us is what was that number originally? It was some number times itself gave us 36. So when you take the square root of 36, everybody knows that that is going to be 6, right? Child's play. You guys have done this probably many, many times. So we can kind of take that same definition if you take a look at down at the bottom as a general definition for what we're talking about here. So if we're talking about the nth root of A is equal to B, that means that B to some n power is equal to A. Hey there. Okay. Questions there on that slide? Everybody remember those root things, right? Okay. All right. So let's talk vocab. A lot of people call this green thing the square root, but it's not a square root symbol. We use it to talk about the square root, but we also talk about it when we use the third root or the cube root, fourth root, fifth root, blah, blah, blah. That symbol is actually called a radical symbol. A radical sign, a radical symbol. Okay, that is the radical. The number that's on the outside in the blue is called the index. That is what root you're looking for. Or what number was it originally taken to that power. And what's inside is the radicand. The whole thing all together. The whole thing all together is a radical. So, radical. It's a radicand.
You just made that word up.
It's actually the name of a Pokemon. I'm just kidding. It's not true.
Would you find it?
What?
You catch it?
That's why it's there. I already caught it. Radicand.
Yeah,
There's a lot of vocab that kind of throws you off. Like you don't really talk about things that way. Kind of like when you talk about division, right? When you say, well, what's the answer to a division problem?
Yeah, talk about
The
fish.
quotient.
Oh yeah.
Okay. When you're doing subtraction? No.
I don't even know. I thought you were talking to him.
My eyes aren't cross-eyed, bro. Just looking at you. Whatever. Moving on. Everyone has this? We're good to go? Alright. So, let's do this. Simplify. Start with the third root of 27. Some number to the third power became 27. What was that number? It was 3, right? So there you go, because 3 to the third power is 27. How about the third root of 216? You guys stop and take some notes, please? Thank you. Proud. You too, Jake. What? 9? 9? 9? 6. How about this one? The fourth root of 256. 8. Come on. Oh, 4. Snap.
Wait, what was it?
I thought it was 8 too, but it's 4. Okay. How about the fifth root of 243? I wanted to say 3. But I wanted to say 8 on the last one, so.
Oh, how do you pick up
It's
the
3.
four?
It's 3?
Oh yeah, it's
Alright, good. It's 3. So, but you guys understand this, right? There's nothing I have to explain too much about finding certain roots of something. Okay. So, now, how about when we have a fraction? When we have a fraction, okay? It's the same thing. You're just going to separate the two. Okay, so in the top, if you think about the fourth root of 16, well, you can see that that's going to be what? 2 to the 4th? And then that would be 3 to the 4th? Yeah?
That's all it is.
And so the fourth root of 16 over 81 is simply 2/3. Okay, so just treat them separately, doing different as 2 parts. Okay. What did I ruin? Oh, 2/3. Yeah. So there's our 2/3. Their writing is prettier than mine. Okay. Questions on the fraction one?
So you wanted you to remember?
Yeah, you do. Now, I do want to point something out though. Let's say you did have the fourth power of, let's say that wasn't 16. Let's say that was 17. Okay? Let's say that was 17 over 81. Okay? Obviously, you can see that the fourth root of 81 is going to be the 3, right? But you don't know there's no fourth root of 17, right? You can actually leave it as the fourth root of 17 over 3. You're going to simplify what you can. And whatever you can, you're just going to leave it alone. Okay? Because we don't have that rational number yet. That makes sense? So if there's something that doesn't have a root, leave it that way in its radical form, but always try to simplify what you can. How about this one? I do have to say that these always mess me up because I don't remember which way to take the 0.
8.
It's going to be 8?
No, we have to go down one more.
It's going to be 4, right?
Yeah.
4.
So, because 4 times 4 is 8, 8 times 4 is... Okay. 4 times 4 is 16, 16 times 4 is 64. But the 0 thing is the one that messes with me the most. So, okay, it's going to get smaller, so it'd be 0.4 to the third. Yeah, I always want to add zeros for some reason. Because you know how the roots are usually smaller? I always have to think about it. Okay, I'm on the other side of the decimal. The add symbol. Crystal clear? Crystal clear, man? No, never mind. Another reference to Breaking Bad. Never mind. I'm gonna move on.
Oh, that's a TV show.
I watch TV. All right, the principal roots. Let's take a look at the rules that we need for the principal roots. Okay? Whoa, don't get all crazy about it, okay? If n is even and a is positive or 0, then you can say that the nth root of a represents a principal nth root of a. But what is the condition there? N has to be even, and a has to be a positive or a 0. And the difference here is that if we have this subtraction symbol, which we call a negative sign, right? In some cases, represents the negative nth root of a. So all we're really talking about here, pretty much, is a positive root versus a negative one, okay? So we can't say positive because it's a principal root, and then we have the negative root of something. Now, if n is even and a is a negative, then it's not a real number, okay? And I think you guys talked about this in Algebra 3, right? What do we actually call that number? If it's not real, then it's imaginary. It's what?
Imaginary.
No, what'd you say before?
Irrational.
Oh, okay.
Imaginary.
All right.
I didn't finish the word.
Okay, it doesn't count, huh? If n is odd, then there's exactly one real nth root of a, written as the nth root of a. Oh, that's getting hot in here. Ah, nice. Guys have a lot to talk about today. It's chitty chatty, chitty chatty. Well, they're not talking to me, they're talking to each other.
They miss each other.
Aw, that's sweet.
I'm just like, this happened, this happened.
Because they're too busy in their
So,
conversation.
conversation.
Or they know where they're just choosing to ignore me, which is cool too. Alright, then it was the other one. No. I was talking at you because you weren't listening. I was saying how much I did miss you guys. I really did. I really do. And I don't say that like I'm not trying to be funny, but you guys are like a really good class.
Who's your favorite class?
I would hate to tell you because then it would go to your head.
It's like
Wait,
weird hours.
Oh,
So it's
Right. I think I did tell you, didn't I? You guys really are my favorite class. You guys, I am really grateful for you guys. You guys are a good bunch. I mean, everybody is, but you guys are like extra.
What is it?
Huh?
Your 6 hours
Yours-
is there.
I get to start my day
your
with you
6
guys.
hours says that whenever they come in, you're like already angry, like you're just like over it. They said you're really mean.
I'm not mean. You should come in 6 hours.
Isn't that what
6 hours is almost like my 4th hour. And I mean, I like them. They're all good kids, but I'm gonna have to talk to them because I'm not mad at them. I'm not.
They're just like, he's like already in a bad mood whenever you walk in.
What class do you have Shane in?
Who's Shane?
6 hours. Who's Shane? 6 hours.
Who's Shane?
Shane the Muhammad.
He's with my Dom and Gabby.
Oh, Mustafa?
Mustafa.
Oh, that's right. His first name's Shane, huh? I have him 6 hours.
You call him Mustafa?
I just call him Mustafa. I love it.
He says you.
I thought about it, but I don't know if I was going to get it. Alright, anyways. Finding each root.
As he's recording.
As I'm recording it. You know I love you, Mustafa. Take your earbuds out. So find each root. What's the square root of 36, guys? 6. How about the square root of negative square root of 36? Negative 6. The 4th root of 16? 2. And the negative fourth root of 16? Negative 2. How about the fourth root of negative 16?
Isn't it not?
It's an imaginary. Like that. Yes.
Yeah, this is going to be imaginary, so it's not a real number. We say it's not a real number, okay? How about the...
Are you going to make us do those, like, all the way out?
Well, you've already done this, so yeah.
So we can't just write not a real number.
No, probably... Well, I might let you get off. At the
You
beginning.
should.
We'll see what the system does, okay?
You should.
I should.
Yeah, see that?
No.
I did that shit.
How about the fifth root of 243? Do you guys remember what it was?
3.
It was 3. How about the fifth root of negative 243? Not a real number. Whoa, no.
What?
Now, okay, I'm sorry, yeah, I slipped. Now, why is that negative 3? Yeah, this is an odd root, okay? Because if you think about it, you can have negative times a negative times a negative times a negative times a negative, right? And still be negative at the end. The only time you really have to be careful, according to the rule, is when you have your index is even, okay? When your index is even.
It's not a real number.
No, it's real. And it just got real. Alright, so let's take a look at the graphs, okay? Let's take a look at the graphs. The graph is actually a pretty simple one. It looks like this. This is the parent function. And you can see right over here where the function is. That's going to be simply be f of x is the square root of x. Here's what it looks like. Memorize it. Make sure you know what it looks like. That's going to make it easier to know what's happening to it.
I have a question. Can you go back over it?
Back to here.
Yeah. Oh, I was right. Okay. I thought you. You can change it now.
All right,
Thank you.
Permute. Permute combination. Shane Mustafa, that's right.
Mustafa, that's quite badass.
Isn't it though? I love it, dude. That's a great last name. Make me want to change my name.
Wasn't it like
I'm not Munoz, I'm Mustafa.
the lion? Mustafa.
Mufasa.
Mufasa.
I don't think he's.
Okay, so they gave us a domain of this thing. Oh, actually, they gave us both. Do you understand why the domain and the range are from 0 to infinity? Because on the domain we start at 0 and we go off toward infinity. Same thing on the range. We start at 0 and it goes up towards infinity. Okay, that means forever. Here's your cube root function. Very similar, except because in a cube root you have that odd index. That means you can get negative roots out of that. So that means it's also going to go in the other direction. So you can have both parts of it. These are a little bit less slopey, but you're going to have that S-looking shape. Hey, Christopher, I'm alright. I feel like I'm half asleep.
I feel like
Yeah.
I'm just wanting my grandparents. My nose is like, can you say
Okay. We're good? No? That's crazy.
We're pretty tired.
Why are you actually so
I've got a feeling.
I can see him running through the desert.
What time is it? Time for you to get a watch.
Okay, got one.
Why did you
Hey Jake,
pick my stuff?
go.
He was
Why do algebra books always look unhappy? Because they have lots of problems.
Oh.
I don't know what I'll take it.
Oh, that's harsh.
Let's hear it.
Well, that sounds like one for me. Let's hear it. Where this?
Why did you suddenly realize you need a math tutor?
Don't pay attention in class.
Because you even failed the vertical line test.
Oh.
That's hard.
Oh, like height.
No.
Okay, I guess you did.
Oh, the line test you take?
No.
She's good at those.
For functions.
About that.
Moving on. Okay,
No.
so let's take a look at this graph here.
What's the word for line test?
Okay. For each function, you can use the table of values to try to. Hello.
Right here.
I know, we're listening.
I know it's getting towards the end of the year. You guys are getting there really antsy. But
The
think
end of the
about
year, we
this
have
though.
months.
Just think about this. You have a whole new semester of all this, so you can't afford to.
Why would
This
you do
semester
that?
went by
Isn't
fast,
senior year
though.
like
It is.
Really fast.
Your senior year does go by fast.
second semester? Aren't you just supposed to let us?
I'll tell you this. Once you get,
Back.
I get really bad. When you get to your graduation night, you're gonna. There's a couple things I've learned. You're gonna be like, these 4 years really didn't feel like 4 years, and then after the summer, you'll know who your friends really are.
Like, I know who my friends are now.
No,
No,
you think you know who your friends
I
are now.
really do. Like, I only have like 4 friends.
Wait till after the summer and then come
You're
back.
gonna have like one person.
You have four?
And your,
No,
your
all the real ones, you know, like-
and your cousins don't count, okay?
Acquaintances and then there's like people who are.
All right, so we want to sketch this table. Let's pick some values to put in here, so that we can get a sketch of this. And then, of course, you're going to want to give the domain the range. Excuse me. So we're going to pick x. It's going to provide for us f of x. So what I'm going to suggest to you. Now, see, this is where the old traditional thing doesn't really help us. You know, you would say, oh, just pick 0, 1, 2, 3, right? Obvious ones. But here's what happens when you pick numbers like that. If I pick 0, 0 plus 2 is 2. What's the square root of 2?
So like
It's,
4 and
well,
6,
it's not. There isn't one. Okay? We can approximate it, right?
4 and 8.
We can approximate. I'm sorry, I didn't mean to do that. We can approximate it, but we don't really know what it is. Okay? I'm sorry.
Be like, no.
So let's. I feel horrible now. I'm bad. I'm bad people.
Just wait.
So let's pick stuff that's gonna make this nice for us, okay? Like 2, right? 2. If I pick 2, 2 plus 2 is gonna give me 4, and the square root of 4 is 2. So I know that's gonna work. I can also pick something like negative 2, right? If I put negative 2 in there, negative 2 plus 2 is gonna give me 0, and I know the square root of 0 is just 0. Something else. What else could I pick? 7? Because if I put 4 in there, let's do that. Okay? What is the square root of 6? Just not 3. Huh?
I got suspended for that.
Isn't it a?
Right. We can approximate it, but I don't think we're going to get it, yeah? So let's pick something that's going to be nice, that we know has a nice square root. Like 9. No, 9 has a square root, right? So how can I get that to be a 9 inside? If x was 7. So then I would go from there, okay? So let's see here. Negative 2, 0 is here. Then I've got 2 goes here. Oh, did we get 0 in there? Oh, that would give us a funky number, huh? Did we put 0 in there? We forgot the square root of 1. We could put negative 1 in there, right? Negative 1 would give us 1. And the square root of 1 is just 1. So I can get another point in here. So that's a little bit better, right? And I know that it has to take on this shape. So I can just do that. So let's talk about the domain here. Domain. What are the values of x this can be? Let's have the dojo pick somebody.
Wait, say your question?
Oh. Shiznits.
Shiznits. What is that, like nibnits?
It was me not saying that
What was the question?
S word. Wait,
What the
where?
domain of that was? Let me put it back up. We're just looking for this domain. Ah, dang it. That didn't work. Go away.
Got me to clap in my butt.
What? How can you not be happy? Look at the little monsters. Do you know they make you smile?
It's on the point.
They're beautiful. Look, it's so cute.
I'm a weird one.
And then he asked me to buy it.
Wait, what was your question again?
He asked you to buy it.
So let me put it back up here, right here. And, and what we came up with, sorry.
Oh, you asking for domain and range?
Yeah, we were looking for
That's all
domain
you
range,
gotta-
right?
That's all you gotta say.
So we had, it looked like this, right? It was like 0, 1, 2. So we're talking about domain and the range of this.
Does it stop at negative 2?
Oh, well, yeah, it's a dot dot. I see what you're saying. I'm sorry. It took me a minute. It's a dot dot.
That's where it ends right there?
No, that's where it starts.
Well, that's as far as it goes.
That's a start. Yeah, that's the starting point. Okay, and it goes on. And I'm sorry I couldn't get it to point a little bit upward more, but I think you get the point.
This way too, like when we're up.
It could, but does this one though? This one does not. Okay. So let's see here. Everybody have an answer? Thank you.
You're welcome.
How do I close that? There we go. All right, cool. Let's pick somebody. Hudson. I'm just kidding. You look like you got scared. All right, let's go see Brittany Hernandez.
Would it be,
What's the domain?
would it be negative 2 something?
Beautiful. Absolutely right. Absolutely right. The domain is, let's see here. We're going to go, okay, yeah. Oh my God, man, I can't even think. And that's going to go off to positive infinity, parenthesis. All right, let's talk about range. Range. Everybody have an answer? Range. So let's go range. Where's my thumbs up? Participating. Range of this function goes to Jacob. Jacob already had it. What is it, bud?
0 to positive infinity.
0 to positive infinity is absolutely correct. You are the man. So range is going from 0 to positive infinity, just like that, yeah?
No.
What? From 0 to infinity. What happened? Josh?
Parentheses instead of brackets.
Oh, parentheses instead of brackets. So
No, not on both sides.
I'm so bad at I'm trying. I can't even right now. I'm like,
I could tell because you like smiling.
well, it makes me happy when I get.
No, like you're really excited like, that you messed up.
No, I love math. What are you talking about? I always get excited all the time.
I was like, really?
All right, so there's that one. Okay, let's try. Come on, this one. Go. Let me stop you there. Thanks. No, actually, go ahead. Keep going. Finish up your thought. Do you guys remember what the original shape looked like? Looked like an S, didn't it? Okay? Looked like an S. So this one's going to look like this. So I can move it, and here's what I want you guys to kind of know. All that I can do with these functions is change how curvy they are, and I can move up or down, left or right. That's all you can do. Does that make sense? So if I were to, can I move? Gosh darn it. Let's say I was going to move the centerpiece of it to here. It would still take on, even if I made it really curvy. You see that? What is the domain and range of this always going to be? Negative infinity to positive infinity. What about range? Same thing. So whenever you see, and they're asking for the domain range of a cube root, it's always going to be both infinities.
No matter when it's a cube root?
Yeah, no matter what. Even if I made this really skinny and want to put it right here, and be like, oh, that was not that skinny, but
So negative infinity to positive infinity.
on the domain, what about the range?
Same.
Do you see why though?
Every time.
Do you see why though?
Yeah.
Then there you go.
Wait, how can you be changing like the turbulence?
It depends on what number's up front here. Remember how we had mx plus b? On the m part would change the slopiness of it, kind of. And I call it slopiness because it's not a real word, but that gives you the idea of what I'm talking about. So if this had a little m up front, which we actually call that a in these functions, then it would change how steep it is, kind of thing. Or unsteep, I should say. Steep or unsteep. So there's our... Oh, I went the other way. My bad. Sorry. But see, it's still negative infinity to positive infinity, no matter where I put it. All right, finding the nth root of nth powers. And you're going to need some rules, so write these rules down. Ba-da! Now, for any real number a, the square root of a squared is the absolute value of a. That is, the principal square root of a squared is the absolute value of a. What?
They just cancel out, right? The square root and
They would. And that's why it's important that we introduce this absolute value here, okay? So let me, before I go on to the problems, say a little bit more about this because it can't be something that you just write down. You got to know why that's the rule, okay? Consider this. If I just did, let's go with 3 squared. We already know that the square root and squaring are inverses of each other, correct? And a lot of people will just go, bow, that's 3. Right? A lot of people will do that. Agree? So, if I presented to you, excuse me, the negative, well, sorry. If I took this and we followed that same idea, bow, that's just negative 3. You'd be wrong, okay? You'd be wrong in this case. Because if you have to think about what squaring something does, Hudson. Okay? If I take a look at this problem from the inside, I'm saying that I'm going to take this negative 3 times itself. How many times? It's going to be positive, right? So it's going to be positive. So if I did this, that would mean I would end up with the square root of a positive 9, which means it's a positive 3. So we can skip all that work if we follow this rule. And we're saying, hey, you know what? If I'm taking something square, like negative 3, I want to make sure that that's the absolute value of negative 3. Therefore, that's the reason why it's 3. Okay? Because sometimes you're not going to get a value in there. They might tell you this. They might say, hey, I want you to take the square root of negative x squared. Okay? And if I just told people that's a negative x, and then I say, oh, you know what? Turns out that x was 5. What would your solution be? It would be a negative 5. Okay? So what you need to do is you can drop the negative if you want, because we know it's going to be positive, right? No matter what. So even if x was a negative 2, throw it in there. Throw it in an absolute value. Even if we did this. What did I have up there just like that? Okay? People would just say x, wouldn't you? Okay? Oh, you know what? That's just x. Yes, that would be wrong. Okay? And let me tell you why. I did some more math. Turns out x is negative 2. So what's the solution here? It would be negative 2, right? By our standards. Don't we just substitute the answer back in? Correct? But if we had done it to the original problem, you see that? That means I would go negative 2 times negative 2, making it a positive 4, and the square root of 4 was simply a positive 2, and not a negative 2. So you have to make sure that you do this absolute value. So even when you do get the true solution later on, or the value of x, when you plug it back in, you still come out with the same result. Okay?
the absolute value
for this one. Now, let me tell you what it has to be there. And I think the next slide might do it for us. Here. If n is an even positive integer. So, if the root we're taking is an even positive, do I have to worry about if it's odd? No, because I can have those negatives happen. Negative, 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 which are not going to be a negative, right? But not if it's going to be a positive root. Sorry, an even root. Okay? So let's go back to here. Let's take a look at some of these examples here. Find the absolute value of this. Well, here it's just, right? So you're going to go with 15. Absolute value of 15. Here, okay, if you can see ahead, it's just going to be 12, right? It's because it's the absolute value of negative 12. How about here?
Absolute value.
Absolute value of y. Can I change, simplify it down to y?
Yeah.
I cannot.
I know.
Because I don't know the value of y. What if y turns out to be a negative again? Okay? So make sure that that stays there. Otherwise, it would make it wrong. Okay? Does that make sense to everybody? And same thing over here. Even if that is a negative y, absolute value of negative y, but it becomes absolute value of y. Because it has to stay positive. Because even here, if we're talking about the absolute value of a negative 3, it's just 3, correct? So, again, back to this rule. If n is even, then we're going to worry about the absolute value bars. If it's an odd index, then we don't have to worry too much about it. Okay? It's simply going to be the a value, or whatever root you get. Okay? So, here's an example. Do I have to worry about the root here? Those absolute value bars?
Yes.
In this case, I do need to worry about it. Why? That's an even root. So, if I take a look at this, that's going to be a 5 to the 4th. That means that's going to end up being the absolute value of negative 5, which is simply 5. So, if you're like Josh, you can see 2 steps ahead, then that's just 5, right? How about in this bottom one? Here, that is a negative 5. Okay? Because it's an odd root. Okay? It's an odd root, so I don't have to worry about absolute values. So these can cancel. And I'm just going to get what's inside. Do I need to worry about my bars here?
Yes.
Yes, I do. Okay? So in this case, and this case is a little bit more interesting. This is still going to be a negative 3. Now tell me why. Because there's that negative index, right? That negative root outside. The negative root of something. So what I'm really doing here is that negative absolute value of the negative 3, just like I would. I'm even kind of ignoring this for now. Okay? But then I say, oh, well, that's just a 3, isn't it? But there's that negative up front, which makes that a negative 3. Okay, just some little nuances, but to get you there. How about the last one? Do I need to worry about absolute value?
Yes.
Yes, I do. Okay, what's that going to look like?
Negative to the m to the 4th.
Yeah, this is going to be negative absolute value of m to the 4th.
The test.
M squared, not 4th. Squared. Okay. Now, here's a good question. I want you to notice they didn't put the bars in there on this one. Why? On the last one, they did not include the absolute value bars. We knew we had to worry about it, right? We had to worry about it here. Nice and loud?
What? Was that right?
I don't know what you said. I want to hear it.
If you square it, it's going to come out to be
Exactly right. No matter what you put in there, that square is going to take care of the negative again. Okay? Now, how did that end up being 2 and not 4? Power over root, guys. What's the power of this m? 8. What is the root of it? 4. What's 8 divided by 4? 2. Okay? You guys remember that power over root rule? Good. Power over, if you don't, you know it now. Power over root.
You should say 20 days to this.
Okay. Let's take a look at D. Do that on your own right now. Go. Give me an answer. I'm going to call somebody.
You don't have the number.
Caliente.
Which one has to be odd for you to not have to put the absolute value?
Here. And the index. What's this going to be?
The absolute value of y.
This one?
No, you said the bottom.
Yeah, here you don't have to worry about it. So. Let's see here. Pearl, what'd you get for D?
I don't do it because I don't get it.
We're on slide 21.
No, just like the last few months.
Okay, so let's use that power rule or that power over root rule, okay? What this is really saying, now do I have to worry about those absolute value bars? No. Look here first, okay? Is it even? Then I don't have to worry about the bars. Simple enough? Okay, so now I'm going to write this as x is 24 over 3. Remember that? What's 24 divided by 3? Mm-hmm. So this is x to the 8th. That's it. Okay? I can do that. Okay.
Why do you think you're...
Let's take a look at this one. Serena, do I have to worry about my bars on this E?
Yes.
It's an even index, so yeah, I do. Okay? So, absolute value of 18 over 6, which happens to be absolute value of y to the 3rd. The pitcher doesn't lean forward, dude. Okay, calculator. Let me end this real quick. I'll show you guys on the calculator how to do that. Minimize this.
Now we need to do the calculation. Today we just got through it.
December.
We always get through it. Okay.
I wish we did.
If you just need to take the square root of something, take a look at the x squared button. Right above it is a radical symbol. That is simply the square root of something. It's going to look like that. Throw the number you want to square root in there, and you're good to go. Now let's say you want to take a higher root of something. So an index higher than 2. Math. Option 4 is the 3rd root. Option 5 is the xth root. Okay? So now let me show you what 4 looks like. So it's going to look like that. Whoa, that's not what I want to do at all. So this is if I want to take the square root of something. So if I want to take the square root of, I don't know, 9, there's my 3, okay? If I hit that math button, option 4, I can take the 3rd root of 27. There's my 3. But let's say I want to take the 5th root of 243. The 5th root, so this is how you're going to have to do it. You're going to have to push that 5 first. Then you're going to go back into math. And then you're going to hit that 5 there. So option 5, see how it kind of throws it up there now? And then you're going to go 2, 4, 3. And then you can get your 3 out of that, okay? Questions? All right, cool. That makes us done.